At dawn, the U.S. Navy's most expensive warship cruised off Virginia. Its crew ran a routine so practiced it seemed untouchable. Yet deep below the flight deck, something quietly waited, a newly installed laser weapon drawing more power than a hospital, ready to shift naval warfare. Why risk installing this untested technology now? The answer would appear before breakfast. At 6:45 a.m., the USS Gerald R cut through the Atlantic, 180 nautical miles off the Virginia coast. On the flight deck, the day's rhythm unfolded with practiced precision. 23 crew members in color-coded jerseys moved between lines of parked jets and humming equipment. Yellow shirts, aircraft directors stood out, arms raised, signaling an A-18E Super Hornet into position. Every gesture was sharp, every step measured. Nearby, purple shirts checked fuel hoses connected to the jet's drop tanks, scanning gauges and seals for any sign of a leak. The Ford's flight deck stretched over 1,000 feet, a floating airfield built at a cost of $13.3 billion. 4 EMALS catapults, each one a marvel of electromagnetic engineering, sat ready beneath the deck plates. Unlike the old steam-driven systems, EMALS delivered smoother, faster launches using stored electrical energy from the ship's twin nuclear reactors, supplying the power that made those launches possible. Each launch was a test of timing and teamwork. Checks completed, the nose wheel of the A-18E locked into the catapult shuttle. The pilot waited for the final signal, helmet visor down, gloved hand poised on the throttle. Above the routine, the Ford's real value revealed itself in moments like this, hundreds of tons of aircraft, fuel, and ordnance moving with the certainty of a well-rehearsed play. The ship's power, its technology, and its crew operated in perfect sync. But beneath the familiar choreography, something new waited, technology not yet part of the daily routine, but about to prove its worth. 14 weeks before that morning in the Atlantic, a team of engineers from Raytheon and Lockheed Martin stepped onto the Ford's pier at Norfolk. Their task was to integrate a weapon that demanded more from a ship's power grid than any system before it. The high-energy laser with integrated optical dazzler and surveillance system, called Helios, arrived on heavy lift trucks, encased in steel and wrapped in warning labels. At 9,200 pounds, and standing 14 feet high by 20 feet wide, the unit was designed for a space just below the carrier's island on the starboard side, where the superstructure's shadow fell across the deck. The Ford's twin A-1B nuclear reactors made this installation possible. Each reactor could deliver 300 megawatts of electricity, more than enough to run the ship's catapults, elevators, and radar, and still have hundreds of megawatts in reserve. The Helios system required a continuous draw of 150 kilowatts, a fraction of the available power, but a leap beyond what older carriers could provide. Technicians spent 96 hours rerouting cables, tying the laser's power feeds directly into the main distribution panels and integrating its controls with the carrier's combat systems. Cooling lines, fiber optic bundles, and data relays snaked through bulkheads and conduits, linking the laser's emitter, sensors, and surveillance arrays to the nerve center deep inside the hull. The beam itself, invisible to the naked eye, operated at a wavelength of 1,064 nanometers, just beyond the visible spectrum. Every component, from the laser's power converters to its gyro-stabilized platform, was calibrated for the ship's constant motion and the salt air. With the installation complete, the Ford became the only carrier afloat with a directed energy weapon ready for operational use. Radar screens in the Combat Information Center flickered as a new contact appeared at 6:51 a.m. The track came in low, just above the surface, moving fast and steady. For 31 hours, a P-8 Poseidon had monitored a converted fishing trawler edging along the continental shelf, its course flagged for irregular maneuvers. Now that vessel sat 8.7 nautical miles northwest of the carrier's heading, well inside the Ford's defensive envelope. Crew in the Combat Information Center exchanged clipped updates as the contact signature changed. At 6:52 a.m., a small object lifted off the trawler's deck, accelerating to 67 knots and climbing through 200 feet, then 350 feet, then 480 feet. Data from the Poseidon's last pass confirmed the profile, a Shahed 136, Iranian-made, 11.5 feet long, with a delta wing and a single propeller. The drone's guidance system, paired with a low-cost GPS receiver, locked its course toward the Ford. Its warhead, a shaped charge weighing 80 pounds, was designed to punch through steel. The cost to build it was around $20,000. On the carrier, the Combat Information Center's watchstanders tracked the threat as it closed the distance. At its current speed and heading, the Shahed would intercept the Ford in just over 6 minutes and 40 seconds. Sensors handed off the track from the Poseidon to the ship's own radar and optical arrays. Altitude, bearing, and speed updated every second. The Ford's defensive systems calculated firing solutions. The drone crossed 7 nautical miles, now well within the ship's engagement range. The urgency in the Combat Information Center was palpable. Each second shaved from the intercept window, each number on the screen a reminder of how quickly a routine morning could turn into a test of survival. Inside the Combat Information Center, the tactical action officer watched the Shahed's track sweep closer. Standard protocol called for a missile intercept. 42 RIM-116 rolling airframe missiles sat ready in their launchers, each one $1 million insurance policy with a range of just over 5 nautical miles. But the officer glanced at the numbers: a $20,000 drone, a $905,000 missile, and a carrier worth over $13 billion. The order came at 6:53 a.m. clear and clipped. Engage with Helios, designated target inbound unmanned aerial vehicle, bearing 315, range 7.2 nautical miles. The fire control team ran the calculations. Activation required 2.3 seconds. Helios, tied directly into the ship's electrical grid, drew 150 kilowatts from the A-1B reactors, barely a flicker in the power flow. Gyroscopes brought the emitter online, compensating for the ship's 4-foot roll as it pushed through the Atlantic swell. Optical sensors scanned for a thermal signature. The drone's engine, running hot, stood out against the morning air, a 180 degrees Fahrenheit contrast, easy for the system to lock onto. The fire control officer checked the specs. Helios was rated for lethal effect at over 1.2 miles, but geometry and clear air gave the team confidence at more than 6 nautical miles. Some doubted the numbers. Atmospheric distortion, sea spray, and the curve of the Earth all worked against the beam. But the data held. Target range 6.8 nautical miles, closing fast. The laser's tracking computer solved for lead, adjusting for the Ford's own 12 knots. No missile launch, no smoke, no noise, just silent readiness. In the Combat Information Center, a quiet tension settled as the system armed. Helios was primed, waiting for the final command. At the instant the Helios emitter locked on, a column of energy 12 inches wide and carrying 150 kilowatts per square inch crossed nearly 7 miles in a fraction of a second. The laser's point of impact was the Shahed 136's left wing, 4.7 feet out from the fuselage. In the first second, surface temperature soared past 1,400 degrees Fahrenheit. White paint blistered, then peeled. By 2.1 seconds, the fiberglass matrix began to unravel, bonds snapping apart as heat burrowed deeper. At 3.6 seconds, a hole had burned through, starting smaller than a fist, widening as the composite dripped away. 4 seconds in, the wing's aluminum spar glowed, then softened. At 5.1 seconds, the metal reached its melting point, 1,220 degrees Fahrenheit, buckling under stress. The wing structure failed. The drone lurched, rolled, and at 6.3 seconds, the wing tore free. The airframe tumbled, losing lift. It plunged, striking the Atlantic at 6:54 and 47 seconds in the morning. A fountain of spray shot 40 feet skyward, then faded into the morning haze. A second drone lifted off from the trawler at 7:02 a.m., followed by a third at 7:08 a.m. Each time, the Helios system tracked, locked, and fired. 3 drones in total, each costing around $20,000, were destroyed in less than 20 minutes. The total cost in electricity to the carrier was under $5. 74 minutes after the first launch, a Coast Guard cutter intercepted the trawler. Members of a maritime security response team boarded and found the launch rails still warm. The crew insisted they had strayed off course due to navigation problems. No arrests followed, but the evidence was clear. 36 hours later, the USS Gerald R returned to Norfolk. Within a week, orders went out to begin Helios installation on the USS John C. Stennis and the USS Harry S. Truman. What began as a test had become the new standard for defending the fleet. Lasers are no longer the future, they are active on the world's most powerful warships. As drone threats multiply and missile arsenals grow, every adversary now faces a defense that fires at the speed of light and costs pennies. War at sea just became a contest of innovation, not just firepower.